Greetings! Today I've got another power bank to have a look at. This one I got from Lidl. That was from Lidl. I always confuse the two. Anyways, this one is a solar power bank. I haven't had a solar power bank here yet, and yeah, this is my first one. So it's Silvercrest brand from Lidl, as I said, SLS 2200. Solar charger capacity 2200 milliamp hours, 3.7 volts, input 5 volts, 500 milliamps, output 5 volts, 1000 milliamps. Okay, so I've had this for about a week or so. We went camping and I picked this up in Lidl on clearance. There was one stray unit lying around and I thought, oh, okay, I'll take that with me since we're going camping, so I can power up my phone and other stuff. Anyways, so it worked okay. I was a little bit disappointed with the solar charging capability. It did take quite a while, actually almost a whole day in direct sunlight. If it ever gets cloudy, the charging is not so great, but yeah, I guess in an emergency, if you haven't got anything else, it will do the job, just really slowly. So on the outside, first we've got a on-off button, indicator that's that this indicator shows that it's charging a device, so the output is on. When the solar panels are active, when they produce electricity, the solar bit LED comes on, and there is a 4 LED charge indicator thing. Two outputs, well, 2 ports, 5 volts output and 5 volts input, and that's about it on the outside. It comes in a kit with instruction manual and those little things that you're meant to stick on the back and perhaps stick it on your windshield inside the car, which I was doing. But the really annoying thing is when you put them on, because the way they placed them, every time you put this on, it squishes the little suckers and it's not going to stick. And so yeah, this one sticks, but every time I was pulling it on and off, I had to pull this off, which is a little bit, yeah, you know, if they only placed it maybe a half a centimeter more outwards, that would have not happened. But anyways, not a big deal, I guess. So let's test what sort of current goes in and out. So I've got the USB meter here, and let's plug this in, and it demonstrates all LEDs. And it's worth noting this USB port is quite recessed, so not every cable is going to work very well. But here we've got 5 volts on the input, and it's drawing about 400 milliamps, 420, so just under specified 500 milliamps. I haven't tested the full capacity on this, and probably I won't, but we're probably better off opening it up and see actually what's inside. Anyways, let's plug this other way around. We need to keep it upside down, and there we go. It's putting out 4.93 volts, which, oh, it jumped up to 5.09, or maybe it was just switching on. Oh, 4.97, and it switched off. 4.93. It does say in the manual that if there is no load detected, or very insignificant load, like just this USB meter, it will switch off very shortly. So let me plug in a fairly power hungry device. and see what it can put out. So let's switch it on, and it's putting out 680, just under 700 milliamps, so a little bit under the full load specified. And worth noting, you can't see that actually, the voltage dropped to 4.73 volts, so that's really low. It's stretching the limits of the low end of USB specification, so a little bit weak on a 4.6, 4.7, so that's really low actually. The current went up to 870, so almost 0.9 of an amp, and we've got 4.6, 4.7 volts output, so a little bit weak actually. Anyways, in the instruction manual, it might be my English and not understanding this, but a warning notice at this hazard level indicates a potential for property damage. Failure to avoid this situation could result in property damage. What situation? A warning notice at this hazard level indicates a potential for property damage. I don't get it. Anyways, it also says never open the housing of the device. There are no user serviceable or replaceable components inside the device. Right, and I'm gonna be the judge of that. Where's my screwdrivers? Let's use this set, and first look on the outside. There isn't a single screw anywhere, but those side panels, from what I see, are stickers. So usually there would be a screw hiding beneath the sticker, and bingo, we've got one. So let's peel this whole thing off. 2 and 3. Okay, let's put that in a safe place. Is the other one the same? So we've got hidden 6 small Phillips screws. Okay, and that's how it comes apart. So the panels come off. The panels are just cheap ABS, and the rest of it is covered in this rubbery feel type of thing that usually deteriorates after a year or so. So yeah, not a big fan of that. Some glue somewhere. I can see already a big battery. Some clips, and we're in. There we go. So the battery's got a protection circuit attached to it, and that goes onto this little board. We've got the solar panel underneath the battery, and that's been heat staked in place, so that's not coming off. And the battery itself, yeah, it's been stuck with another foam pad like this underneath there, so yeah, it's not coming off because this glue is quite aggressive. But anyways, we can have a look at what sort of chips they are using. There's a little bit of some sort of red gunk. And there's one chip, the bigger one, that is absolutely nameless. there isn't, it's not that I don't see it, it's there isn't any markings on it. So oopsies. 1 2 3 4 5 7, so it's a 14 pin device. Not sure what that is. The little thingy here is SI4606, I think, and a few smaller components. Big inductor here, that's for the DC to DC conversion, and yeah, oh, it looks fairly busy for a little power bank. Let's see what's on the other side. Not much, just the LEDs and a button. Oh yeah, that reminds me, I've got to be careful because this is live, so I don't want to short out anything because things will go up in smoke rather quick. I wanted to look up what this chip is, and as soon as I saw it, it became obvious. It's a MOSFET, because you can see all the pins on one side are they go into one pad. So yeah, this essentially is a 3-pin device just in a bigger package. So this is the MOSFET doing the switching on and off for high current, but other than that, I think the whole control is done through this. By the way, it does support pass-through, so as you can see on this picture, it's charging from USB, and it's the output is on as well, and it's putting out some light to this LED lamp. And the same case with solar, it will charge through solar and charge your phone at the same time. So I guess that's a nice feature. And I guess those Germans knew what they were talking about when they said there's no user serviceable parts inside, mainly because, well, there's no markings on them, so you don't know what you're dealing with. And the battery hasn't got a marking, but it's a fairly big size battery, but it's very thin. So the way this is arranged inside, you could easily fit at least 3 times the volume of this of the one that's currently inside. But then again, how long will it take to charge using this panel? And the panel, by the way, has got 1 2 3 4 5 6 7 8 9 10 cells in 2 rows. What I've noticed is I could, when this was in full sunlight, they must be wired up in series, because as soon as I covered just a small section like so, it would stop charging across 2 of them basically. But if I covered 1/2 of it like so, it still indicated that it's charging okay. So clearly, by breaking the sun path across both rows of cells, that basically stopped charging. So I'm deducing that this is in series and this is in series, and those 2 are put in parallel. So when I did it like this bit was still fine, and it was producing current to go into the battery. But as soon as I went like that, it would have stopped it. So a little bit disappointing teardown. Not much doing inside. Everything is obscure. So anyways, for as boring as it was, I hope you enjoyed it, and that's it for this one. Subscribe for more random stuff. For the time being, take care.